Close your eyes, feel the weight of your body settle. Let the present moment fade away. Now, step backward through time. Not years, not centuries, but thousands of years. Keep going. Further, deeper into the past. You are standing somewhere you have never been. Somewhere no modern human has stood in living memory. Open your eyes. You are on the surface of Pangea. It is happening right now, deep beneath your feet. A force so vast, so silent, and so slow that you will never feel it move. Yet, it determines the shape of every continent, the depth of every ocean, and the very air you breathe. Imagine the Earth not as it is today, but as it was 200 million years ago. A single colossal landmass dominates the globe. This is Pangea. It stretches from the northern pole to the southern ice, a contiguous empire of stone and soil encompassing over 150 million square kilometers. It is a world where you could walk from the future site of New York to the deserts of North Africa without ever touching the sea. From the jungles of Brazil to the coast of Nigeria without crossing an ocean. But deep within the Earth, roughly 2,900 kilometers down near the boundary of the core and mantle, heat is building. The core, burning at over 5,000 degrees Celsius, nearly as hot as the surface of the sun, is restless. It sends massive plumes of superheated rock rising slowly through the mantle like wax in a lava lamp. These plumes strike the underside of the Pangean crust. They burn, they push, they weaken the stone foundation of the world. In our timeline, the inevitable happens. Around 175 million years ago, the crust cracks. Great rifts tear open the land. Volcanic fissures spew lava for millions of years, flooding an area of 11 million square kilometers. The great supercontinent is torn asunder. The Atlantic Ocean is born, pushing the Americas away from Europe and Africa at the speed of a growing fingernail, roughly 2.5 centimeters per year. But what if it didn't? What if the heat trapped beneath the crust found a different way to escape? What if the mantle plumes cooled just enough to fail? What if the rifts, instead of tearing the world apart, simply settled back into silence? Imagine a world where Pangea never broke, a world where the Atlantic Ocean never formed. A world where humanity, if it evolved at all, rose on a planet with one single endless ocean and one infinite unbroken land. What would the weather be like on a continent so large that its interior never sees rain? What monsters would evolve in a single unified ecosystem where no species is ever isolated? Tonight, we drift back 175 million years to the moment of the break, and then we simply stop it. We are going to watch a new history unfold, a timeline of endless deserts, hyper-monsoons, and a civilization that knows no borders because there are no continents to divide them. This is the story of the world that almost was. CTA 1. If you enjoy journeys like this one, consider subscribing. There's much more waiting for you. To understand how Pangea could have remained whole, we must first understand why it broke apart. The science of our shifting Earth is relatively young. For centuries, cartographers looked at the maps of the world and noticed a peculiar coincidence. The coastline of South America seemed to fit perfectly into the curve of Africa, like two pieces of a jigsaw puzzle cut by a giant hand. But for a long time, this was dismissed as mere chance. It was in 1912 that a German meteorologist named Alfred Wegener dared to suggest otherwise. Wegener proposed the theory of continental drift. He didn't just look at the shapes of the continents, he looked at the fossils. He found remains of the freshwater reptile Mesosaurus in both Brazil and southern Africa. He found identical fern fossils, Glossopteris, across India, Australia, and Antarctica. These creatures could not have swum across thousands of miles of open salt water. Wegener realized that the land must have once been connected. He called this lost supercontinent Urkontinent, which later became known as Pangea, Greek for all lands. Wegener's evidence was compelling. But the scientific establishment of his day could not accept such a radical idea without a mechanism. How could solid continents plow through the ocean floor like ships through water? Wegener proposed that the continents drifted due to tidal forces from the Moon and the centrifugal force of Earth's rotation. This was quickly dismissed as insufficient by physicists who calculated that such forces were far too weak to move landmasses weighing trillions of tons. Wegener died in Greenland in 1930, ridiculed by the geological community because he could not explain how the continents moved. His body was found frozen in the ice, a solitary explorer who had seen the truth but could not prove it. For 3 decades, his theory languished in obscurity, dismissed as the work of an outsider who didn't understand the permanence of the Earth's crust. It wasn't until the 1960s that the mechanism was revealed. During World War II, a naval officer and geologist named Harry Hess used sonar to map the ocean floor. He expected to find a flat, ancient seabed. Instead, he found a world of towering underwater mountain ranges, the mid-ocean ridges. These ridges stretched for over 65,000 kilometers across the ocean floors, forming the longest mountain chain on Earth. Hess proposed sea floor spreading. He realized the ocean floor was moving, spreading out from these ridges like a conveyor belt, at rates of 2 to 10 centimeters per year. The evidence came from magnetism locked in the rocks. As molten lava erupted from the mid-ocean ridges and cooled, iron-rich minerals aligned themselves with Earth's magnetic field, like tiny compass needles frozen in stone. Scientists discovered that these magnetic stripes on the ocean floor were symmetrical on both sides of the ridges. Even more remarkably, the polarity of the magnetism alternated in bands, north-seeking, then south-seeking, then north again. This was because Earth's magnetic field reverses roughly every 200,000 to 300,000 years, a phenomenon that had been independently confirmed from volcanic rocks on land. This work was visualized by the brilliant cartographer Marie Tharp, who created the first detailed maps of the ocean floor, revealing the rift valleys that ran down the center of the Atlantic. Working with geologist Bruce Heason at Columbia University's Lamont Geological Observatory in the 1950s, Tharp painstakingly plotted thousands of sonar depth readings. She proved that the Earth's crust is divided into massive tectonic plates. These plates float on the semi-molten asthenosphere, driven by the intense heat currents we mentioned earlier. The theory of plate tectonics was born. By 1968, the scientific revolution was complete. The Earth's lithosphere, the rigid outer shell, is broken into 7 major plates and dozens of minor ones. These plates move in response to convection currents in the mantle beneath them. Hot material rises from deep within the Earth, spreads laterally beneath the crust, cools and sinks back down. This cycle, driven by the heat of radioactive decay in the Earth's core and mantle, is the engine that moves continents. At divergent boundaries, plates pull apart and new crust is formed. This is happening today at the Mid-Atlantic Ridge, where Europe and North America are separating at roughly 2.5 centimeters per year, about the rate your fingernails grow. At convergent boundaries, plates collide. When an oceanic plate meets a continental plate, the denser oceanic crust is forced down into the mantle in a process called subduction. This creates deep ocean trenches like the Mariana Trench, which plunges to a depth of nearly 11,000 meters. When 2 continental plates collide, are rising today at a rate of 5 millimeters per year. The Himalayas are rising today at a rate of 5 millimeters per year as the Indian plate drives into the Eurasian plate. This collision began roughly 50 million years ago and continues to this day. Mount Everest at 8,849 meters is still growing. We now know that Pangea was not unique. It was simply the latest in a cycle known as the Wilson cycle, named after Canadian geophysicist Tuzo Wilson, who proposed it in 1966. This cycle describes how supercontinents form and break apart roughly every 400 to 600 million years. Before Pangea, there was Rodinia, about 1 billion years ago. Before that, Nuna, roughly 1.8 billion years ago. Even further back in deep time, there may have been Kennerland, around 2.7 billion years ago, though the evidence becomes increasingly fragmented the further we look into the past. The Earth breathes in a rhythm of hundreds of millions of years. Continents crash together to form a supercontinent, insulating the mantle beneath them. The trapped heat builds up until the crust can no longer take the stress. It domes upward, cracks, and the supercontinent rifts apart, beginning the cycle anew. This cycle is tied to fluctuations in global climate, sea level, and even the evolution of life itself. When continents are dispersed, as they are today, the sea levels are higher because the mid-ocean ridges are actively spreading, displacing seawater. When continents collide to form a supercontinent, the ocean ridges become less active, sea levels drop, and vast continental shelves are exposed. The climate becomes more extreme, with hotter summers and colder winters, because land heats and cools faster than water. Ice ages become more likely. Pangea began to form around 335 million years ago, during the late Carboniferous period, when the continents of Laurussia and Gondwana collided, creating the Appalachian Mountains and the Ural Mountains. By 270 million years ago, at the end of the Permian period, the assembly was nearly complete. Pangea stretched from pole to pole, covering roughly 1/3 of Earth's surface. The remaining 2/3 was the Panthalassa Ocean. The interior of Pangea was unlike any environment we see today. Rainfall could not penetrate more than 1,500 kilometers inland. Beyond that distance, the land was a hyper-arid desert called the Pangean Megamonsoon Desert. Computer climate models suggest that summer temperatures in the interior exceeded 55 degrees Celsius, while winter temperatures dropped below freezing. These temperature swings of more than 70 degrees Celsius would have created violent windstorms as hot air from the interior rushed toward the cooler coasts. The coastal regions experienced the megamonsoon, a seasonal weather pattern far more intense than anything we see today. During the summer, the supercontinent heated up, creating a massive low-pressure zone that pulled moisture-laden air from the Panthalassa. The result was months of continuous torrential rain along the eastern and western coasts. In winter, the flow reversed, and the coasts became dry while the interior remained a barren wasteland year-round. Then, around 200 million years ago, when the first cracks appeared. The Central Atlantic Magmatic Province, one of the largest volcanic events in Earth's history, began erupting along a line that would eventually become the Mid-Atlantic Ridge. Over a period of about 600,000 years, an estimated 4 million cubic kilometers of basaltic lava poured out, covering an area of 11 million square kilometers. This event coincided with the end Triassic extinction, which wiped out roughly 76% of all species. The rifting continued. By 175 million years ago, in the early Jurassic, the Atlantic Ocean was born as a narrow seaway. North America separated from Africa. South America began its slow drift away from Africa. By 130 million years ago, the South Atlantic was opening. India broke free from Antarctica and Gondwana, beginning its northward journey toward Asia. By 65 million years ago, at the end of the Cretaceous, the continents were recognizable, though still closer together than they are today. But the breakup of Pangea fundamentally changed the planet. Ocean circulation patterns shifted, creating new currents that distributed heat more evenly around the globe. Isolated land masses allowed evolution to take different paths, creating the biogeographic diversity we see today: kangaroos in Australia, lemurs in Madagascar, unique finches on the Galapagos Islands. The separation of continents also increased the length of coastlines, which in turn increased shallow marine habitats, leading to an explosion of marine biodiversity. In our scenario, we are interrupting this Wilson cycle at a critical juncture. We are asking physics to behave slightly differently. We are freezing the engine of the Earth just enough to halt the breakup, but not enough to kill the planet. What if the mantle plumes that drove the rifting were slightly cooler? What if the convection currents in the mantle shifted their pattern by just a few degrees? What if the stress in the crust found a different outlet, perhaps through increased volcanic activity at the edges of the supercontinent, rather than through continental rifting? It is not an impossible scenario. Supercontinents have existed for hundreds of millions of years in the past. Rodinia endured for roughly 350 million years before breaking apart. Pangea could, theoretically, have lasted far longer than it did. The breakup was not inevitable on a timescale of millions of years. It was simply the most likely outcome given the buildup of heat and stress. But in the vast landscape of possibility, there exists a timeline where the right combination of factors aligned to keep Pangea whole. And that is the timeline we are exploring tonight. A world where the Atlantic never opened, where the continents remained fused, where the drama of life unfolded on a single immense stage, with consequences we can barely imagine. This is the world we now turn toward, a world of permanence in a reality defined by change. Let us descend into this ancient world, the Pangea of 200 million years ago, just before the divergence. It is the Triassic Period. The air is warm, thick and heavy. Oxygen levels are lower than today, hovering around 15%, making the air feel thin at high altitudes. Carbon dioxide levels are high, creating a potent greenhouse effect that keeps the planet sweltering. To the east lies the vast Tethys Ocean, a massive triangular bay that cuts into the side of the supercontinent like a giant mouth. To the west, north and south lies the Panthalassa, the All-Sea, a global superocean that covers nearly 70% of the Earth's surface. It is an ocean so wide that a tsunami generated on one side would take nearly a day to reach the other. The interior of Pangea is a place of extremes. Because the landmass is so huge, the moisture from the oceans cannot reach the center. The heart of the continent is a vast arid wasteland, a desert larger than the Sahara and Gobi combined. Here, temperatures swing violently. During the day, the red sands bake at over 50 degrees Celsius. At night, the temperature plummets below freezing. The silence here is absolute, broken only by the cracking of stones cooling in the twilight. Yet, life endures. In the cooler, fern-filled rift valleys, we find the Lystrosaurus. This pig-sized herbivore, with its tusks and beak, is the great survivor of the previous mass extinction. It shuffles through the undergrowth, digging for roots, unaware that it is walking on land that will one day become Antarctica. In the shadows of the ancient ginkgo trees stalks the Cynoognathus, a predator with fur and warm blood, a distant ancestor to mammals. It hunts with speed and agility, sensing the vibrations of its prey through the ground. Along the edges of the Tethys, where the rainfall is heavy and the humidity oppressive, early dinosaurs are beginning to rise. The Plateosaurus, a long-necked giant reaching up to 10 meters in length, browses on the high branches of the Dicroidium seed ferns. It is a world of reds and greens, of rust-colored soil and emerald forests. The Appalachian Mountains are here, but they are not the worn-down hills we know today. They are jagged, towering peaks as high as the modern Himalayas, casting long shadows over the central plains. The climate is dominated by the mega monsoon. Because the landmass is so large, it heats up much faster than the ocean. In the summer, the hot air over Pangea rises, pulling in moisture-laden winds from the Panthalassa. The resulting storms are apocalyptic. Rain falls not in drops, but in sheets, flooding the coastal regions for months on end, turning dry riverbeds into raging torrents kilometers wide. Then, in winter, the flow reverses, and the continent dries out completely. The geography of Pangea is a study in contrasts. If you were to walk from the northern polar regions down toward the equator, you would traverse through distinct climate zones, each more extreme than the last. The northern reaches, where Siberia and northern Canada are fused together, are locked in perpetual cold. Snow covers the ground for 10 months of the year. The permafrost extends down hundreds of meters. Here, only the hardiest conifers survive, ancient relatives of modern pines and spruces, their trunks twisted by the wind, their roots clinging to frozen soil. Moving south, you descend into the temperate belt. This region, roughly where Europe and eastern North America are joined, experiences a brief, explosive summer. The snow melts rapidly in the spring, creating vast wetlands that teem with life. Amphibians dominate these swamps. Massive Mastodonsaurus, a temnospondyle the size of a crocodile, lurks in the murky waters, waiting for unwary prey. Its flat, wide skull, nearly a meter across, breaks the surface like a mossy boulder. It is patient. It has waited here for hours, breathing slowly through nostrils positioned on top of its head. The forests of the temperate zone are thick with cycads, tree ferns, and early conifers. The undergrowth is a dense tangle of primitive club mosses and horsetails, some growing to heights of 5 meters or more. There are no flowers yet. Angiosperms? The flowering plants will not evolve for another 50 million years. The forest floor is carpeted with moss and fern fronds, damp and spongy underfoot. The air smells of decay and growth, of soil and spores. In these forests roam the early archosaurs, the ancestors of dinosaurs and crocodiles. Coelophysis, a slender bipedal predator about 3 meters long, moves in packs through the undergrowth. It is quick, agile, and intelligent by the standards of its time. Its bones are hollow, making it light and fast. It hunts small reptiles, insects, and the occasional juvenile Lystrosaurus. Its eyes are sharp, its movements deliberate. The pack communicates with soft hisses and chirps, coordinating their hunt with a precision that hints at the complex social behaviors that will later define the dinosaurs. Further south, as you approach the equatorial regions, the temperature rises steadily. Here, along the coasts of the Tethys Ocean, the climate is hot and humid year-round. The sky is often overcast, heavy with moisture. When the sun does break through, it is blinding, reflecting off the wet leaves and turning the forest into a cathedral of green light. The humidity is oppressive, reaching 90% or higher. Water drips constantly from the canopy. Every surface is slick with algae, moss, or fungal growth. This is the realm of the Plateosaurus and its kin. These early sauropodomorphs, the forerunners of the great long-necked giants of the Jurassic, browse on the high canopy. A fully grown Plateosaurus can reach 10 meters in length and weigh over 4 tons. It walks on all fours when feeding, rising up on its hind legs to reach the topmost branches of the dicroidium ferns and early ginkgo trees. The dicroidium is everywhere here. Its distinctive forked leaves create a rustling canopy that sways in the humid breeze. The coastal plains along the Tethys are vast and flat, stretching for hundreds of kilometers inland before rising into the foothills of the central mountain ranges. During the monsoon season, these plains flood completely, transforming into a shallow sea dotted with islands of higher ground. Life here is amphibious by necessity. The Gerathorax, a bizarre, flat-bodied amphibian with external gills, spends its entire life underwater during the wet season, only crawling onto land during the dry months to lay its eggs in the mud. The Tethys Ocean itself is warm, with surface temperatures averaging 28 to 30 degrees Celsius. It is a shallow sea, rich in nutrients washed down from the land. The waters are murky, stained brown by sediment. Near the shore, the sea is crowded with marine reptiles. Nothosaurus, a sleek, long-necked predator about 4 meters in length, patrols the shallows, its webbed feet propelling it through the water with powerful strokes. It feeds on fish and smaller reptiles, and occasionally coming ashore to bask on the muddy banks. Further offshore, the tethys drops into deeper waters where larger predators reign. The early ichthyosaurs, dolphin-like reptiles with streamlined bodies and large eyes, hunt in the open water. These are the Mixosaurus, relatively small ichthyosaurs about 1 meter long, darting through schools of primitive bony fish with astonishing speed. They are built for endurance, capable of diving to depths of 50 meters or more in pursuit of prey. But the true giants of the tethys have not yet arrived. The massive pliosaurs and mosasaurs of later eras do not exist. The ocean is still a frontier, a relatively safe place compared to the land. The great marine predators of the Triassic are the placodonts, strange, heavily armored reptiles with crushing teeth designed to crack open shellfish. Placodus, looking almost like a reptilian walrus, dives to the seafloor to pry mollusks from the rocks with its protruding front teeth, then crushes them with the flattened teeth at the back of its jaw. As you journey inland from the Tethys coast, the land rises into the great mountain chains that crisscross Pangea. The Appalachian-Mauritania-Variscan belt runs in a continuous line from what will become North America through what will be North Africa and into Europe. These mountains are young and tall, their peaks capped with snow even at the equator. Glaciers cling to the highest peaks, the carving U-shaped valleys and depositing massive boulders as they advance and retreat with the seasons. The mountain slopes are barren above the tree line, which sits at roughly 3,000 meters elevation. The thin air and extreme cold make this a hostile environment for most life. Only the hardiest lichens and mosses cling to the rocks. But in the valleys and lower slopes, where rivers fed by glacial melt carve deep gorges, there are pockets of remarkable biodiversity. These valleys act as refuges, isolated from the extremes of the supercontinent climate. Here, species persist that have long since vanished from the lowlands. Crossing the mountains and descending into the interior of Pangea is like entering another planet. The landscape changes abruptly. The green forests give way to scrubland, then to rocky desert. The soil becomes thin and dusty, the color of rust. The temperature soars. By midday, the ground is too hot to touch. Heat mirages shimmer on the horizon, though creating phantom lakes that vanish as you approach. This is the Pangean megadesert, a hyper-arid wasteland that stretches for over 4,000 kilometers from east to west and 2,000 kilometers from north to south. It is the largest desert in Earth's history, covering an area of roughly 8 million square kilometers, larger than the Sahara, the Arabian Desert, and the Gobi combined. Rainfall here averages less than 25 millimeters per year. In some regions, rain does not fall for decades. The silence of the megadesert is profound. There is no birdsong, no rustle of leaves, no hum of insects. The wind is the only sound, a constant low moan that rises and falls across the empty dunes. The sand itself is fine and red, rich in iron oxide. When the wind picks up, it creates dust storms that can last for days, blotting out the sun and turning the sky a deep, apocalyptic orange. Yet even here, life finds a way. The Tanistropheus, a bizarre reptile with a neck longer than its body and tail combined, hunts along the rare oases and ephemeral lakes that form after the occasional rainstorm. This creature, reaching lengths of up to 6 meters, is an enigma. Its extraordinarily long neck, stiffened by elongated vertebrae, allows it to stand on the shore and dip its head into the water to catch fish without ever wetting its body. It is a creature perfectly adapted to a world where water is precious and danger lurks beneath the surface. In the deep desert, where even the Tanistropheus cannot survive, there are only the hardiest of reptiles. Small burrowing lizards emerge only at night when the temperature drops below freezing. They feed on insects, seeds, and the occasional desert plant, tough, spiny succulents that store water in their thick leaves. These plants are not true cacti, which have not yet evolved, but convergent forms, ancestors of modern succulents that have independently discovered the same survival strategy. The nights in the mega-desert are cold, clear, and astonishingly beautiful. With no moisture in the air to scatter light, the stars burn with fierce intensity. The Milky Way stretches across the sky like a river of light. The moon, slightly closer to Earth than it is in our time, appears larger and brighter, casting shadows sharp enough to read by if there were anyone to read. At the far western edge of Pangea, where the land meets the endless Panthalassa Ocean, the climate shifts once again. The western coast is wetter than the east, buffeted by storms that cross the entire breadth of the superocean. The mountains here, the ancient ranges that will one day become the western Cordilleras of North and South America, intercept the moisture-laden winds, creating rainforests on their western slopes. These forests are different from those of the Tethys coast. They are darker, cooler, shrouded in mist. The trees are draped with epiphytes, ferns, mosses, and primitive liverworts that hang from every branch. The forest floor is a spongy mat of decaying vegetation, perpetually damp, smelling of rot and rebirth. Fungi dominate the understory, their fruiting bodies erupting in bizarre shapes and colors, some as large as dinner plates, others as small as pinheads. This is the domain of the Eoraptor, one of the earliest true dinosaurs. Small, only about a meter long, Eoraptor is a lightly built, bipedal predator with a long tail for balance. It is opportunistic, feeding on anything it can catch: insects, small reptiles, eggs, and carrion. It is not yet dominant. The world still belongs to the archosaurs, the Rauisuchians, and the large amphibians. But Eoraptor represents the future. In its bones is written the blueprint for the terrible lizards that will one day rule the Earth. The southern regions of Pangea, where the future continents of South America, Africa, India, Australia, and Antarctica are fused together, form the vast landmass known as Gondwana. The climate here is somewhat cooler than the north, moderated by proximity to the South Pole, but the pole is not yet frozen. There is no permanent ice cap in the Triassic period. The southern forests are temperate, dominated by seed ferns, conifers, and ginkgos. In the river valleys of southern Gondwana, vast herds of Cannemeieria, a large dicynodont herbivore, graze on the lush vegetation. Cannemeieria is a massive creature, weighing up to 500 kilograms, with a barrel-shaped body, powerful limbs, and a beaked mouth. It is a social animal, traveling in herds of 20 or more individuals for protection. The herds follow the seasonal rains, moving hundreds of kilometers each year in great circular migrations. The rivers of Pangea are unlike any we see today. Many of them are seasonal, flowing only during the monsoon months, then drying into chains of isolated pools during the dry season. The fish trapped in these pools must survive for months with dwindling oxygen levels. Some species have evolved the ability to breathe air, using primitive lungs to supplement their gills. These are the ancestors of the lungfish and, ultimately, of all land vertebrates, including us. In the permanent rivers, fed by mountain glaciers, the water is clear and cold. Here, large amphibians like the Metaphosaurus dominate. This creature, with a skull over 60 centimeters long and a body stretching to 3 meters, is an ambush predator. It lies motionless on the river bottom, covered in silt, waiting for fish or small reptiles to swim overhead. When prey approaches, it lunges upward with surprising speed, its wide mouth engulfing the victim whole. The skies above Pangea are patrolled by the pterosaurs, the first vertebrates to achieve powered flight. These early pterosaurs are small, with wingspans of less than a meter. They feed on insects which are abundant and diverse. The late Triassic is the age of the giant insects, dragonflies with wingspans of 30 centimeters, beetles the size of a human hand, and millipedes over a meter long. The low oxygen levels of the Triassic have caused insects to evolve smaller sizes than in the Carboniferous, but they are still far larger than their modern descendants. As the sun sets over Pangea, the land is painted in shades of red and gold. The long shadows of the mountains stretch across the plains. In the forests, the diurnal creatures retreat to their burrows and nests, while the nocturnal hunters emerge. The night belongs to the mammal-like reptiles, the cynodonts and the early mammals, tiny creatures no larger than a shrew, scurrying through the undergrowth in search of insects and seeds. This is Pangea, a world of extremes, a world of brutal deserts and violent monsoons, of towering mountains and endless plains. A world where life clings to the edges, to the oases, to the rivers and coasts, while the vast interior remains a silent, empty heart. It is a young world, still shaping itself, still evolving. And it is on the brink of the greatest change in its history. The world is about to break apart. But in our timeline, it will not. In our timeline, Pangea endures, and now we change history. The year is roughly 175 million years before the present. The Central Atlantic Magmatic Province, a massive volcanic region, is primed to erupt. The pressure builds beneath the crust, the rock strains. But in our timeline, the energy dissipates. Perhaps the convection currents in the mantle slow down by a fraction of a percent. Perhaps the mantle plumes shift slightly to the north, venting their heat harmlessly into the ocean floor rather than against the continental keel. The tension releases not with a crack, but with a sigh. The volcanic vents smoke and sputter, but the land does not tear. The rift valley that would have become the Atlantic Ocean fails to open. North America remains fused to Africa. South America stays locked in the embrace of the southern lands. The moment passes. The Earth continues to spin. The sun continues to rise over the Panthalassa Ocean. But the geography is frozen. Pangea endures. This is the pivot. This is the moment where our alternate timeline branches away from the history we know. It is a subtle change, almost invisible on a human timescale. No catastrophe announces it. No volcanic eruption shakes the world. The rifting simply stops. The cracks that have begun to form along the eastern coast of what would become North America remain shallow. They fill with sediment. They heal. The Atlantic Ocean, that vast body of water that will one day separate continents and define civilizations, remains a phantom, a possibility that never materializes. What happens to a world where the continents are trapped together forever? What happens to the climate when the Atlantic Ocean never opens to regulate the temperature? What happens to evolution when there are no isolated islands, no separate continents for species to diverge? We are left with a single, colossal arena for the drama of life. Consider the implications. In our world, the separation of continents created biodiversity through isolation. When South America drifted away from Africa roughly 130 million years ago, the ancestors of New World monkeys evolved separately from their African cousins. When India broke free and journeyed north, it carried with it unique flora and fauna that would develop in complete isolation for tens of millions of years. When Australia separated, marsupials flourished in the absence of placental mammal competitors. Isolation is the engine of speciation. But on Pangea, there is no isolation. When every species competes directly with every other species across the entire landmass, there are no protected pockets where unusual evolutionary experiments can unfold undisturbed. There is no Australia where kangaroos can hop without fear of big cats. There is no Madagascar where lemurs can evolve into bizarre forms. There is only one continuous ecosystem stretching from pole to pole where the strongest, fastest, and most adaptable survive. What does this mean for evolution? Does it accelerate, driven by relentless competition? Or does it stagnate, with dominant species suppressing novelty? We are about to find out. Because in this timeline, the Jurassic period arrives not with a reshuffling of continents, but with Pangea intact. The dinosaurs that rise to dominance in the late Triassic do not spread across separating landmasses. They spread across one endless continent. Think about the climate. In our world, the opening of the Atlantic Ocean created new ocean currents. The Gulf Stream, carrying warm water from the Caribbean to the North Atlantic, keeps Europe significantly warmer than it would otherwise be. The circumpolar current around Antarctica isolates the southern continent in a ring of cold water, maintaining its ice sheets. Ocean currents distribute heat around the globe, moderating extremes and creating the climate zones we know today. On Pangea, none of this happens. The Panthalassa. Ocean remains a single vast body of water, circling the supercontinent. Ocean currents form in massive, simple gyres, undisturbed by complex coastlines. Warm water accumulates at the equator with nowhere to go. Cold water remains locked at the poles. The result is a planet of extremes. The equator becomes hotter. The poles become colder. The temperate zones that support the greatest diversity of life become narrow bands squeezed between fire and ice. And the interior of Pangea? That vast desert at the heart of the continent grows larger, not smaller. Without the moderating influence of nearby oceans, the land continues to heat and cool in violent cycles. Summer temperatures in the deep interior regularly exceed 60 degrees Celsius. Winter temperatures plunge to -40 degrees Celsius. The annual temperature swing of 100 degrees or more creates windstorms of unimaginable ferocity as air masses clash at the boundaries between the hot interior and the cooler coasts. The monsoon intensifies. When the supercontinent heats up in summer, it pulls moisture from the Panthalassa with tremendous force. The resulting rainfall is biblical in scale. Rivers that are dry for 9 months of the year suddenly rage to life, hundreds of meters wide, carrying enough water to carve canyons in a single season. Coastal regions that bake in the dry season are submerged under meters of floodwater when the monsoon arrives. Life here is not a matter of gradual adaptation. It is a matter of survival against seasonal apocalypses. But the most profound question is not about climate or geography. It is about us, about humanity. Do we even evolve in a world like this? The evolutionary pressure that drove our ancestors to develop large brains, tool use, and language was, in part, a response to environmental variability and geographic isolation. Small populations of hominids in Africa were separated by mountains, deserts, and changing climates. They had to adapt or die. Innovation was rewarded. Intelligence was survival. On Pangea, there is nowhere to hide. There are no isolated valleys where a small population can experiment with new behaviors. There are no islands where a band of early humans can develop unique cultures without interference. If intelligent life arises at all, it arises under completely different conditions. Perhaps it arises in the monsoon-battered coasts, where predicting seasonal floods becomes a survival skill that demands complex memory and planning. Perhaps it arises in the deep desert, where finding hidden water sources requires spatial reasoning and communication. Or perhaps it never arises at all. These are the questions that now unfold before us. We stand at the pivot point, 175 million years ago, watching as the Earth chooses a different path. The crust remains whole, the continents do not drift, and from this single change, an entirely different history begins to write itself. A history of extremes, a history of unity and competition. A history where the map of the world never changes, but everything upon it transforms in ways we can barely imagine. So we ask, what would life on an eternal Pangea become? How would ecosystems organize themselves across a continent that spans from the Arctic to the Antarctic without interruption? How would climates evolve when the ocean cannot slip between the lands to redistribute heat? How would intelligent life, if it emerged, understand its world when there are no separate lands to discover, no oceans to cross, no frontiers beyond the endless interior desert? This is the journey we now undertake. Not a journey across space, but across possibility. We will watch as the millennia accumulate, as species rise and fall, as climates shift and intensify, all on a single unchanging stage. We will follow the speculative spiral of deep time, imagining a world that never was, but could have been. A world where Pangea endures. But here is where the story gets truly strange. You might assume that a stable Pangea would simply mean a world much like the Jurassic, lasting forever. But a supercontinent is not a stable place. It is a heat trap. Without the breakup, the Wilson cycle is broken. The mantle heat that usually escapes through the formation of new oceans begins to build up beneath the thick crust of the supercontinent. Pangea begins to dome upward, lifting the land higher and higher. The climate does not just stay the same, it intensifies. The deserts grow wider, the monsoons grow more violent. The world enters a state of geological fever. The species trapped on this island world are forced into a pressure cooker of competition. There is no escape, no migration to a new world. Every living thing must adapt to the extremes of the supercontinent or perish. Consider what this means for the geological forces themselves. In our world, when Pangea broke apart, the heat beneath the supercontinent dispersed along thousands of kilometers of new rifts and mid-ocean ridges. Volcanic activity was spread across multiple zones. But on eternal Pangea, all that heat has nowhere to go. It accumulates. The pressure builds not just in one location, but across the entire underside of the supercontinent. We would see volcanic activity unlike anything in our Earth's history. Not the clean rifts that birthed the Atlantic, but chaotic, unpredictable super-eruptions along the coastlines and mountain ranges. Hotspots would punch through the crust at random intervals, creating massive flood basalt provinces that cover millions of square kilometers. The sky would darken periodically with volcanic ash, plunging regions into years-long twilight. These eruptions would be extinction events in miniature, happening every few million years, resetting the biological clock again and again. The land itself would become unstable. As the supercontinent domes upward from the heat below, the interior highlands would rise thousands of meters. Mountain ranges would form not from tectonic collision, since the continents are locked together, but from vertical uplift. The Pangean interior, already a hostile desert, would become a high altitude, the oxygen-poor wasteland. Life would retreat even further toward the coasts, squeezing into narrower and narrower bands of habitability. And then there is the ocean. The panthalassa, wrapping endlessly around the supercontinent, would become increasingly stratified. The surface waters, heated by the tropical sun and unable to mix with deeper layers due to the simple circular currents, would reach temperatures approaching 40 degrees Celsius near the equator. Or this is close to the upper thermal limit for most marine life. Below this hot surface layer, the deep ocean would be cold, dark, and nearly lifeless. Without the complex circulation patterns created by multiple ocean basins and continents, the ocean would essentially divide into two worlds, a thin, superheated surface and a cold, stagnant abyss. But perhaps most disturbing is what happens to the poles. Without ocean currents to distribute heat, ice would advance. Not gradually, but in sudden surges. Every few thousand years, the ice sheets would expand rapidly, driven by positive feedback loops. White ice reflects sunlight, cooling the region further, causing more ice to form. The polar regions of Pangea would become locked in permanent glaciation. Massive ice sheets, kilometers thick, would grind across the land, scouring it down to bedrock. Yet, at the same time, the equator would be hotter than ever. The planet would be trapped in a perpetual state of extreme imbalance. Fire at the center, ice at the edges, and in between, narrow zones of survivable climate where life clings on, adapting to conditions that swing violently from one season to the next. This is not a stable world. This is a world in constant crisis, a pressure cooker where evolution happens not slowly, but in desperate bursts of innovation driven by catastrophe. The species trapped on this island world are forced into a pressure cooker of competition. There is no escape, no migration to a new world. Every living thing must adapt to the extremes of the supercontinent or perish. And perhaps most hauntingly, every mass extinction event becomes total. When the volcanic winter comes, when the ice advances, when the monsoon fails for a century, there are no distant refuges where survivors can wait out the catastrophe. Everything happens everywhere, all at once. The diversity of life is constantly pruned back, only to explode again in the brief windows of stability. This is the Pangea that endures. Not a peaceful, unchanging monument, but a restless, fevered giant, growing more extreme with every passing million years. And we have not even begun to explore what becomes of the species trapped upon its surface. The real story is only just beginning. CTA 2. If this story is carrying you somewhere peaceful, feel free to close your eyes. The narration will guide you. And so the timeline diverges. 10 million years pass, then 50 million. The Jurassic Period gives way to the Cretaceous, but the map remains unchanged. Without the opening of the Atlantic, the global ocean currents are completely different. In our world, the Gulf Stream carries warm water from the equator to the north, keeping Europe warm. In this world, there is no Gulf Stream. Heat pools at the equator, creating a hot zone of oceans where water temperatures reach 35 degrees Celsius or more. These hot, stagnant seas become dead zones, anoxic and devoid of life, as oxygen cannot dissolve in such warm water. This would mean that the polar regions, cut off from warm currents, become colder much faster. We might see ice caps forming in the extreme north and south of Pangea much earlier than in our history. A world of fire and ice. The equator is a steaming hothouse. The poles are frozen wastelands. The habitable zone for life is squeezed into two narrow bands in the mid-latitudes. Over the next 100 million years, evolution takes a different path. In our world, the isolation of continents allowed mammals to evolve differently in Australia, South America, and Africa. Marsupials flourished in isolation, but on Pangea there is no isolation. Animals can walk from one end of the world to the other. This creates a hyper-competitive environment. Invasive species are not an anomaly, they are the norm. Perhaps the dinosaurs never die out. The Chicxulub asteroid impact 66 million years ago might still happen, but the recovery of the Earth would be different. On a single landmass, the devastation might be more total, or perhaps the recovery faster. As species from the far side of the continent migrate to repopulate the blast zone. If the dinosaurs survive, they continue to evolve. We might see intelligent troodontids developing not in the forests of North America, but in the vast, contiguous jungles of the Central Belt. The mammals, our ancestors, remain small nocturnal creatures, living in the shadows of the eternal reptilian giants. Without the breakup of the continents to create varied environments, the pressure to evolve high intelligence might never come. Or perhaps it comes differently. Perhaps intelligence arises in the desert dwellers, are forced to innovate to find water in the unending sands of the Pangean interior. Let us trace this alternate evolutionary path more carefully, step by step, through deep time. We begin 165 million years ago in what would have been the mid-Jurassic period. On eternal Pangea, the climate has continued to intensify. The interior desert now covers nearly 12 million square kilometers, making it by far the largest desert the Earth has ever known. The monsoon belt has become even more violent. Coastal regions experience rainfall totaling over 10 meters per year, concentrated into just 4 months of continuous deluge. The dinosaurs have diversified, but not in the ways they did in our timeline. Without geographic barriers to isolate populations, there are no distinct continental faunas. The same species of sauropods lumber across what would have been South America, Africa, and Asia. A tyrannosaur-like predator that evolved on one side of the continent can migrate thousands of kilometers to hunt on the other side within a single generation. This creates what ecologists would call a homogenized fauna, highly competitive, highly mobile, with wide-ranging apex predators and cosmopolitan herbivore species. The sauropods have evolved into hyper-specialists. In our world, different continents saw different sauropod body plans: the long-necked brachiosaurs of North America, the bizarre sail-backed amargasaurids of South America, the massive titanosaurs of South America and Africa. On Pangea, competition is so fierce that only the most efficient designs survive. The dominant sauropods are giraffe-like forms, capable of reaching heights of 18 meters to browse on the tallest conifers. They travel in vast herds, sometimes numbering in the thousands, migrating annually along the monsoon belt in circular routes that span 5,000 kilometers. These migrations are the heartbeat of the Pangean ecosystem. Predators follow the herds, scavengers follow the predators. When a herd passes through a region, it transforms the landscape, stripping vegetation, trampling the soil, leaving behind vast quantities of dung that fertilize the next season's growth. The migration routes become deeply worn pathways, visible from space as brown scars cutting across the green coastal belt. And so, 30 million years pass. We arrive at 135 million years ago, through the early Cretaceous. The polar ice caps have continued to grow. The southern ice sheet now extends down to what would be the latitude of modern-day Tasmania, covering roughly 4 million square kilometers. The northern ice cap is smaller but growing, creeping southward from the pole at a rate of about 10 kilometers per century. These ice caps are permanent, fed by the cold, dry air that descends over the poles in the absence of warm ocean currents. This would mean that sea levels are lower than they were in the Triassic. So much water is locked up in ice that the global sea level has dropped by approximately 50 meters. The coastlines of Pangea have expanded outward. The shallow seas that once fringed the continent have dried up, exposing vast tidal flats that stretch for hundreds of kilometers. These flats become new habitats, colonized by pioneering plants. Tough, salt-resistant shrubs and grasses that can survive in the alkaline soils left behind by the receding sea. The flowering plants, the angiosperms, have begun to appear. In our world, angiosperms evolved in isolation on different continents, leading to the incredible diversity of flowering plants we see today, over 300,000 species. On Pangea, the angiosperms evolve in a single unified environment. Competition is brutal. Only the most aggressive, fast-growing and adaptable species survive. The result is a relatively low diversity of flowering plants, but those that do exist are phenomenally successful. One group dominates: the grasses. Grasslands have appeared earlier on Pangea than they did in our world, spreading rapidly across the exposed tidal flats and the transitional zones between the desert and the forest. By 120 million years ago, vast prairies stretch across the mid-latitudes of Pangea, covering an area larger than the modern Great Plains, the African savanna, and the Eurasian steppe combined. These grasslands become the new center of evolutionary innovation. The herbivorous dinosaurs adapt to this new resource. Hadrosaurs, the duck-billed dinosaurs, evolve specialized teeth capable of grinding the tough grasses. They become the dominant grazers, traveling in herds that rival the sauropod migrations in scale. Some species develop social structures more complex than any seen in non-avian dinosaurs in our timeline. They communicate with elaborate vocalizations produced by resonating chambers in their crests. Across the grasslands, the haunting calls of the hadrosaur herds echo for kilometers, a sound like whale song mixed with trumpet blasts. But the story doesn't end there. The evolution of grasslands creates a new ecological niche for predators. Fast, cursorial hunters evolved to chase down the fleet-footed hadrosaurs. These are not the bulky tyrannosaurs of our Cretaceous, but something more akin to therizinosaurs or ornithomimids, lightweight, built for speed and endurance. Some species can sustain speeds of 50 kilometers per hour for extended distances, running down prey through sheer persistence. Over the next 50 million years, this arms race between predator and prey drives both to extremes of specialization. By 70 million years ago, just before the Chicxulub impact in our timeline, the fauna of Pangea is unlike anything Earth has ever seen. The hadrosaurs have become the dominant terrestrial vertebrates, filling the niches that, in our world, would later be filled by ungulates. There are hadrosaurs the size of modern elephants, others the size of antelopes, and some as small as rabbits, occupying the small herbivore niche. The predators have diversified in response. There are pack-hunting theropods the size of wolves, solitary ambush predators that hide in the tall grasses, and even semi-aquatic forms that hunt along the rivers during the monsoon floods. The Pangean Cretaceous is a world dominated by one class of animals, the dinosaurs, but within that class, diversity has exploded to fill every conceivable niche. And then, the asteroid strikes. 66 million years ago, a rock 10 kilometers across slams into the Tethys Ocean at a speed of 20 kilometers per second. The impact releases energy equivalent to 100 million megatons of TNT, roughly 2 billion times more powerful than the atomic bomb dropped on Hiroshima. The immediate blast zone is vaporized. A crater 180 kilometers wide is punched into the seafloor. Tsunamis 300 meters high radiate outward, striking the coasts of Pangea within hours. But the real killer is the ejecta. Trillions of tons of vaporized rock are thrown into the atmosphere. The debris spreads around the globe within days. The sky turns black. Temperatures plummet. Photosynthesis stops. On our Earth, with its separated continents, some regions were shielded from the worst effects. But on Pangea, there is nowhere to hide. The entire landmass is exposed to the same global catastrophe. The darkness lasts for months. Temperatures drop by 20 degrees Celsius. The grasslands wither. The forests die back. This would mean that the extinction is more severe. In our world, roughly 75% of species went extinct, including all non-avian dinosaurs. On Pangea, the extinction rate might approach 85 to 90%. The large herbivores, dependent on continuous vegetation growth, are among the first to go. The hadrosaur herds starve within weeks. The predators, deprived of prey, follow soon after. Within a year, the megafauna of Pangea is gone. The age of the dinosaurs ends not with a whimper, but with a hammer blow. Yet life endures. In the deep burrows beneath the grasslands, small mammals wait out the winter. In the rivers and lakes, fish and amphibians survive on detritus and algae. Along the coasts, where the ocean moderates the temperature extremes, pockets of vegetation persist. These survivors become the founders of the New World. 10 million years later, 56 million years ago, the planet is recovering. The Paleocene forests have returned, but they are different from anything that came before. Without the dinosaurs to crop the vegetation, the forests grow dense and tangled. Vines choke the understory. Ferns carpet the forest floor. The climate has warmed again. In our timeline, this period is known as the Paleocene-Eocene thermal maximum, a spike in global temperatures driven by volcanic activity and the release of methane from the seafloor. On Pangea, the warming is even more extreme. Equatorial ocean temperatures reach 38 degrees Celsius, approaching the limits of habitability for complex life. The mammals have inherited the Earth, but they are not our mammals. The primates that would give rise to humans never evolve because the environmental conditions that drove primate evolution in Africa, the patchwork of forests and savannas, the isolated populations adapting to local conditions, do not exist on Pangea. Instead, a different lineage takes center stage: the ungulates, the hoofed mammals. Over the next 20 million years, these ungulates diversify explosively. By 36 million years ago, to the Eocene-Oligocene boundary, they have filled the niches left vacant by the dinosaurs. There are browsing ungulates with long necks that feed on the high canopy. There are grazing ungulates that roam the grasslands in vast herds. There are even predatory ungulates, descendants of omnivorous ancestors that have evolved crushing jaws and sharp hooves capable of killing prey. But the story doesn't end there. The cooling trend that began at the Eocene-Oligocene boundary accelerates. By 30 million years ago, the polar ice caps have expanded dramatically. The Antarctic ice sheet on southern Pangea now covers 8 million square kilometers, larger than the modern Antarctic ice sheet. The northern ice cap has reached down to the latitude of what would be modern-day Germany. Between them, the habitable zone of Pangea has shrunk to a narrow belt, perhaps 2,000 kilometers wide, where temperatures remain moderate enough for forests and grasslands to persist. This would mean that competition intensifies once again. The animals are squeezed into an ever narrower band of livable habitat. Evolutionary pressures mount. Species that cannot adapt quickly enough are driven extinct. Those that survive are the most flexible, the most intelligent, the most capable of learning and adapting to changing conditions. And here, perhaps, is where intelligence emerges. Not in primates, but in the descendants of those hadrosaurs that somehow survived the asteroid impact. Small, omnivorous avian dinosaurs, the birds, have been quietly diversifying in the forests and grasslands. By 20 million years ago, some lineages have become quite large, flightless, and increasingly dependent on complex social behaviors to survive. One lineage in particular catches our attention. These are the Pangean retites, descendants of early paleognath birds. They stand nearly 2 meters tall, with powerful legs and small vestigial wings. But their most striking feature is their brain. Relative to body size, their brains are 3 times larger than those of their ancestors. They live in tight-knit family groups, cooperate to hunt small mammals, and use tools: sharp stones to crack open nuts, sticks to probe for insects in tree bark. Over the next 10 million years, these birds continue to evolve. By 10 million years ago, in the Miocene, they have become the most intelligent non-human animals on the planet. They have developed a proto-language, a system of calls and gestures that allows them to communicate about things not immediately present: the location of food, the presence of danger, the intentions of other group members. They form alliances, engage in trade, and even conduct what might be called warfare between rival clans. But they never cross the threshold to full human-like intelligence. A rare and fragile thing, a lightning strike of evolutionary fortune that almost never happens twice. The Pangean retites remain in a kind of cognitive stasis, intelligent enough to dominate their ecosystem, but not intelligent enough to reshape the world. Meanwhile, the planet continues its slow dance through deep time. 5 million years ago, the Pliocene, and the ice caps have reached their maximum extent. Nearly half of Pangea is covered in permanent ice, a frozen wasteland where only the hardiest mosses and lichens can survive. The habitable zone has shrunk to a narrow band along the equator, a thin green belt sandwiched between the ice to the north and south and the hyper-arid desert in the interior. This is a world on the edge. The climate swings wildly with the Milankovitch cycles, the periodic variations in Earth's orbit that drive ice ages. Every 100,000 years, the ice advances and retreats, pushing life back and forth across the narrow habitable zone. During glacial maxima, the ice sheets expand and the habitable zone shrinks to just a few hundred kilometers wide. During interglacials, the ice retreats and life surges northward and southward, recolonizing the lands that were buried under ice. The Pangean retites, forced to migrate constantly to follow the shifting habitable zone, develop even more sophisticated social structures. They build seasonal camps, returning to the same locations year after year. They develop oral traditions, passing down knowledge of migration routes, water sources, and safe territories from one generation to the next. They are, in every meaningful sense, a culture. But they never develop agriculture. They never settle down. They remain nomads, forever chasing the edge of the ice. And so, 2 million years ago, the Pleistocene arrives. The Ice Age cycles intensify. The glaciations become more severe, the interglacials more brief. The Pangean retites are pushed to the brink. Their population dwindles. Their range contracts. By 500,000 years ago, they are confined to a few isolated refuges along the equatorial coast, small pockets of forest and grassland that persist even during the worst glaciations. In our world, this is when early humans were spreading across Africa and beyond, and developing ever more sophisticated tools and societies. But on Pangea, the story is different. The ratites survive, but they do not thrive. They are living fossils, intelligent relics of a bygone age, clinging to existence in a world that has grown too harsh, too extreme, too unforgiving. Perhaps in the end, this is the lesson of eternal Pangea. In a world without isolation, without the refuge of separate continents, without the diversity that comes from geographic separation, evolution becomes a treadmill. Species must constantly adapt just to survive, but the opportunities for true innovation, for something radically new to emerge, are limited. The Pangean biosphere is not stagnant, but it is constrained, locked into patterns of competition and extinction that prevent the emergence of anything truly transformative. The mammals never develop human-like intelligence. The birds come close, but not close enough. The planet remains a wilderness, dominated by the rhythms of ice and monsoon, of migration and extinction, of survival and loss. It is a world without cities, without agriculture, without language as we would recognize it. A world where the map never changes, but the struggle for existence never ends. But the story doesn't end there, because evolution never stops. As we approach the present day, the hypothetical now of this alternate timeline, the Ice Age cycles continue. The Pangean retites are gone, or driven extinct by a particularly severe glaciation 50,000 years ago. But other species have taken their place. New forms have evolved from the survivors of each crisis. The treadmill continues to turn. The grasslands remain the dominant ecosystem in the narrow habitable belt. Vast herds of herbivores, descendants of those ancient ungulates, migrate endlessly across the plains, following the rains. Predators follow them. Scavengers follow the predators. The food web is complex and dynamic, but it is also strangely familiar. If you could stand on the grasslands of this Pangea and look around, you would see ecological roles, grazers, browsers, predators, scavengers, that are fundamentally the same as those in our world. The players are different, but the game is the same. And perhaps that is the most profound realization. Life adapts, life finds a way, but the path it takes is shaped by the constraints of its environment. On a world of separated continents, life diversifies into an astonishing array of forms. On a world of eternal unity, life converges on a smaller set of optimal solutions, endlessly refined by competition. Both worlds are alive. Both worlds are dynamic. But they are fundamentally different in their character, their texture, their possibilities. As we stand at the edge of this alternate present, we can see the Pangean world spread out before us, the ice caps gleaming in the polar latitudes, the narrow green belt of the habitable zone, the vast brown expanse of the interior desert, empty and silent, the endless blue of the Panthalassa Ocean wrapping around the world. It is a world that could have been, a world that almost was, a world that, in the vast branching tree of possibility, exists in the realm of the hypothetical, the speculative, the imagined. And yet, in imagining it, we have made it real, at least for a moment, in the theatre of the mind. Let us drift forward to the present day, to the now of this alternate timeline. The year is what we would call 2024, but the calendar means nothing here. The Earth looks like a blue eye with a single brown iris. From space, one side of the planet is entirely water, the deep, dark, endless Panthalassa. The other side is the supercontinent. The climate is defined by the rhythm of the mega monsoon. For 6 months, the skies are clear, the sun beats down, and the land dries into a cracked pavement. Then the clouds gather. Walls of water kilometers high sweep in from the ocean. The dry riverbeds, some as wide as the Amazon, suddenly roar to life. Life here is amphibious, nomadic, or dormant. There are vast forests of hardy conifers that can withstand months of drought. There are creatures like the Titan walker, a speculative descendant of the sauropods, towering 30 meters high, migrating endlessly across the plains to follow the rains. There are the dune runners, flightless birds that have adapted to the deep interior deserts, capable of running at 80 kilometers per hour to find distant oases. If humans exist here, we are not a civilization of nations and borders. How could we be? There are no natural borders, no oceans to cross. We are a coastal species, clinging to the green ring that surrounds the dead heart of the continent. Our cities are built on stilts to survive the monsoon floods. We are a single people, speaking a single root language because we have never been separated long enough to drift apart. We look out at the Panthalassa Ocean with fear and reverence, knowing it wraps around the entire world, a barrier more formidable than space itself. The night sky is the same moon watches over this world. The same constellations wheel overhead, but the silence is deeper here. You can stand in the center of the Pangean desert and be 3,000 kilometers from the nearest drop of seawater. The silence of the stone is absolute, a heavy blanket that has laid undisturbed for 300 million years. Close your eyes now and picture the dawn breaking over this world, the pale light creeping across the eastern edge of Pangea, where the Tethys Sea still laps at ancient shores that have known no other shape for 100 million years. The sun rises not over a fragmented world of islands and peninsulas, but over a continuous landmass that stretches without interruption from the northern ice to the southern glaciers, a distance of more than 12,000 kilometers, unbroken by any strait or channel or inland sea large enough to matter. In the coastal cities, the people wake to the sound of the morning wind, the breath of the continent exhaling after the cool of night, a wind that has traveled across 2,000 kilometers of interior desert without encountering a single tree, a single lake, a single obstacle to slow its passage. The air is dry, crackling with static, tasting of iron and salt and ancient dust. The buildings are low and wide, constructed from baked clay and compressed earth, designed to withstand the seasonal floods that will come in 4 months when the monsoon breaks. The streets are empty now in the dry season, but you can see the high watermarks on every wall, the stains where the floodwaters reached, sometimes 3 meters above the ground, sometimes higher. The lower floors of buildings are uninhabitable storage, filled with sealed containers and provisions that must last through the wet months when travel becomes impossible and the world shrinks to whatever high ground remains above the churning brown water. The people here are not like us, not entirely, though they might be our distant cousins, shaped by different pressures, different needs, different opportunities. They are taller perhaps, or shorter, who adapted to the extremes of heat and humidity that define life on the monsoon coast. Their skin is darker, protection against a sun that beats down with equatorial intensity for 6 months without relief. Their eyes are narrow against the dust storms, their lungs larger to breathe the thin air that prevails at the higher elevations where the cities must be built to avoid the floods. They do not think in terms of countries or nations because those concepts require boundaries. And on Pangea, there are no boundaries that matter, no mountain range high enough to block migration, no desert wide enough to prevent passage forever, no ocean to create an absolute barrier between one people and another. Instead, they think in terms of the seasons, the cycles, the great rhythm of wet and dry that governs everything. They are the people of the coast, the people of the green belt, the people who wait for the rain. Their language is ancient, perhaps tens of thousands of years old, its roots stretching back unbroken through time because there has been no isolation to fragment it, no separate populations to drift apart linguistically, no islands where dialects could harden into distinct tongues. It is a language of gradients rather than categories, with dozens of words for different kinds of wind, different stages of drought, different textures of dust, but only one word that means ocean, because there is only one ocean and it wraps around the entire world like a skin. To travel here is a matter of timing and patience rather than distance and technology. During the dry season, caravans venture into the interior, following ancient routes marked by stone cairns and the bones of those who failed to read the weather, who ventured too far or stayed too long and were caught when the monsoon broke early. These routes wind through the transition zone between the habitable coast and the dead heart of the interior, a landscape of scrub and thorn where water exists only in deep wells dug by generations of travelers, maintained as a sacred duty by those who pass through. The caravans carry goods and information, the currency of a world without clear borders, trading salt and metal and precious woods harvested from the monsoon forests for the produce of distant regions, the amber and jade from the northern latitudes, the volcanic glass from the mountain ranges that run like a spine down the center of the continent, the dried fish and seaweed from the ocean shores. They move slowly, deliberately, with the patience of people who understand that the land is vast and time is abundant, that rushing means death in a world where water sources are separated by 500 kilometers of nothing. In the wet season, travel stops entirely, and the world contracts to the local, the immediate, the village or town or city that sits on its island of high ground while the floodwaters rage around it. This is when the great rivers appear, rivers that exist only 4 months out of every year, rivers that dwarf the Amazon and the Nile and the Yangtze, rivers that stretch for thousands of kilometers from the coastal mountains to the sea, carrying the runoff from half a continent, carving channels 5 kilometers wide and 50 meters deep through the soft sediments of the coastal plain. Each monsoon season, they carve new paths, no defined channels, no names that persist from year to year. Each monsoon season, they carve new paths, find new routes to the sea, leaving behind a landscape of braided channels and oxbow lakes and vast mudflats that dry and crack in the sun when the dry season returns. The geography here is fluid, impermanent, rewritten every year by the power of water moving across a landscape with nothing to stop it. I know dams or levees or human structures substantial enough to redirect such force. Life adapts to this rhythm in ways both familiar and strange. The forests that grow in the monsoon belt are deciduous not in response to winter cold, but to summer drought, shedding their leaves during the dry months to conserve water, then exploding into green abundance when the rains finally come, growing with a speed and intensity that seems almost violent, and as if trying to compress a year of growth into 4 months of opportunity. The trees here have thick, water-storing trunks, bark that can withstand months of desiccation, root systems that reach down 50 meters to tap underground aquifers that persist through the dry season. the animals have evolved strategies equally extreme. The Titan walkers, those speculative giants descended from the sauropod line, are perpetual nomads. Their lives a continuous migration that follows the leading edge of the monsoon, always moving, always walking, their herds stretching across distances so vast that the youngest members at the rear of the herd may be a week's journey behind the leaders at the front. They never stop, because stopping means death in a world where the rain moves on whether you follow or not. They are creatures of astonishing endurance, capable of walking 20 hours a day at a pace of 4 kilometers per hour, covering distances of 80 kilometers between sunrise and moonrise, their long necks swaying with a rhythm that has hypnotized travelers for generations, their footfalls creating a low rumble that can be felt through the ground from kilometers away, a seismic heartbeat that announces their approach long before they come into view on the horizon. The dune runners occupy the opposite ecological niche, creatures of the deep interior, adapted not to follow the rain but to avoid it. Living in the hyper-arid core of the continent, where rain falls perhaps once every 10 years, where life persists not by abundance but by efficiency, by extracting every possible calorie from the sparse vegetation, every possible drop of moisture from the dew that condenses on stones during the brief cool of night. They are birds, flightless and sleek, built for speed across the open sand, their legs powerful enough to propel them at 80 kilometers per hour for hours at a time, outrunning any predator, reaching distant oases through sheer velocity and navigational instinct. They live in small family groups, territorial and fierce, defending their oases against all comers with sharp beaks and powerful kicks that can shatter bone. They are intelligent, perhaps as intelligent as the extinct Pangean retides, capable of solving problems, using tools, remembering the locations of water sources across distances of hundreds of kilometers. But they have not developed language, highs as it is. Along the coasts where the is as it is. Along the coasts where the ocean meets the land in an endless collision of water and stone that has continued unchanged for longer than continents usually exist, there are creatures that live between worlds, neither fully terrestrial nor fully marine. The amphibious descendants of the lungfish lineage that have evolved to exploit the tidal zones and the seasonal floodplains. They are salamander-like in form but massive in scale, some species reaching lengths of 5 meters with muscular tails for swimming and thick limbs for crawling across mud. They breathe air through lungs but can also absorb oxygen through their skin when submerged. They lay their eggs in the temporary ponds that form during the monsoon, the eggs that can survive desiccation if the ponds dry too soon, waiting in suspended animation until the next rains arrive. In the deep ocean, the panthalassa that wraps around the world in an unbroken embrace, the marine life is different from anything we have ever known, because this ocean has no Mediterranean, no Caribbean, no enclosed seas where shallow water species can diversify in isolation. The panthalassa is deep, cold and relatively empty, its surface heated by the tropical sun into a thin layer of warmth that extends down perhaps 100 meters, below which lies the abyss, eternal darkness and cold that has known no change since the ocean formed. The creatures here are pelagic wanderers, travelers of the open ocean, never touching land, never seeing the bottom, born in the surface waters and dying there, their bodies sinking slowly into the abyss to feed the strange, patient creatures that live in the dark. There are fish the size of whales, sleek and silver, feeding on vast schools of smaller fish that roam the surface in migrations that circle the globe following the seasons. There are squid with arms 10 meters long, intelligent and curious, rising from the depths at night to hunt in the surface waters, their bioluminescence creating patterns of light that might be communication, might be camouflage, might be something we cannot comprehend. And far below, where the pressure is immense and the darkness absolute, there are things that have never been seen, that will never be seen. creatures that feed on the rain of organic matter that drifts down from above, patiently filtering the water for particles. Living lives of such slow metabolism that a human lifetime would pass as a single heartbeat to them. The deep ocean of Pangea is a world unto itself, vast and unexplored, and perhaps unexplorable, holding secrets that will die with it when, be in some distant future, the continents finally break apart again and new oceans form, and the Panthalassa is fragmented into smaller seas. Back on land, in the human cities that cling to the coastal belt like barnacles to a stone, there is a culture that has developed without the concept of exploration in the sense we understand it. There are no new continents to discover because there is only one continent. There are no distant shores to reach because the shore is everywhere and nowhere. A continuous line that circles the world but never varies in its essential character. The ocean is not a highway to new lands, but a barrier, absolute and final, a blue wall that marks the edge of the possible. Instead, the culture has turned inward, developing a rich tradition of cyclical time, of seasonal festivals that mark the turning of the monsoon, of oral histories that stretch back thousands of years without linear narrative, because there is no sense of progress, and no movement from one place to another, only the eternal return of wet and dry, heat and cool, abundance and scarcity. The stories they tell are not about heroes who journey to distant lands and return transformed, but about heroes who learn to read the wind, to predict the rains, to find water in the desert, to survive the flood. Their architecture reflects this impermanence, this acceptance that the world is not a fixed stage but a fluid system in which change is the only constant. Buildings are designed to be rebuilt every generation, constructed from materials that can be harvested locally and that decompose back into the earth when abandoned. There are no monuments that last 1,000 years, no pyramids or stone circles or cathedrals, because permanence is an illusion in a world where the rivers change course every year and the coastline shifts with every flood. The technology is sophisticated but appropriate to the environment, are focused on water management and seasonal prediction rather than on conquest or expansion. There are vast systems of cisterns and channels that collect runoff during the monsoon and ration it out during the dry months, maintained by cooperative labor because no individual or family can manage such infrastructure alone. There are wind towers that catch the desert wind and use it to cool buildings and pump water from deep wells. There are solar furnaces that concentrate sunlight to smelt metal without needing wood or coal, precious resources in a world where forests are confined to narrow bands along the coast. The people measure time not in years but in monsoons, counting age by how many rains a person has seen, how many dry seasons they have survived. A person of 20 monsoons is an adult, mature and experienced. A person of 50 monsoons is an elder, a repository of knowledge and memory, valued for their ability to recall patterns in the weather, to recognize the subtle signs that predict an early or late monsoon, a heavy or light rain, a flood that will reach 3 meters or 5. At night, when the work is done and the heat of the day has faded into the cool of evening, people gather on the rooftops to watch the stars wheel overhead in their eternal dance, and they tell the old stories, the stories of the first people who learned to survive on this unforgiving world. The stories of the great floods that came when the monsoon arrived early and caught the caravans in the open. The stories of the deep desert where the silence is so profound you can hear your own heartbeat. The stories of the ocean that goes on forever, that wraps around the world and meets itself on the other side. A concept so vast it feels like infinity. They do not dream of other worlds because this world is all there is, has always been all there is, will always be all there is. The idea of separated lands, of islands and archipelagos and distant continents is not something they can imagine, any more than we can truly imagine a world without time or a universe without space. Their psychology, their philosophy, their art and music and poetry are all shaped by the fundamental truth of unity, of continuity, of the single unbroken land. And perhaps there is a peace in that, a serenity that comes from knowing your place in the world, from understanding that there are no frontiers to conquer, no horizons to chase, no distant shores calling with promises of something better. There is only here, only now, only the eternal cycle of the monsoon and the slow turning of the seasons and the patient endurance of a people who have learned to live within the rhythms of a world that does not change. As you drift deeper into sleep, imagine yourself standing on that rooftop under those stars, feeling the night wind on your skin, warm and dry and smelling of distant dust, hearing the murmur of voices around you, speaking in a language you do not understand, but somehow feel in your bones. A language that has no word for foreign, because everything and everyone exists within the same continuous space, the same shared world, the same single land that has endured unchanged since before memory, since before history, since before time itself had meaning. The silence settles over you like a blanket, deep and ancient and comforting, the silence of stone that has known no earthquake, of mountains that have stood unchanged for 100 million years, of deserts that have seen the same sun rise and set in the same way since the age of the dinosaurs. It is a silence that speaks of permanence in a universe of change, of stability in a cosmos of flux, of the deep time that underlies all things and makes human concerns seem fleeting and insignificant and, ultimately, peaceful. This is the world of eternal Pangea, a world that never was but could have been, a world that exists now only in the realm of imagination and speculation, but that feels somehow more real than reality itself in this moment of half-waking dream, this space between consciousness and sleep, where all possibilities exist simultaneously, and the boundaries between what is and what might be dissolve into the soft darkness of the night. We often think of the ground beneath our feet as permanent. We build our houses on solid ground. We draw lines on maps and call them countries. We fight wars over patches of soil. But the story of Pangea reminds us that the land is not a stage, it is a raft. A raft drifting on a sea of molten rock, pushed by forces we can barely comprehend, on a timescale we can scarcely imagine. The fact that our world broke apart, creating the diversity of continents, cultures and climates we know today, is a result of a geological lottery. We are the children of the rift. We are the product of the spaces between the lands. But in the deep time of the Earth, unity and separation are just phases. Pangea was not the first supercontinent, and it will not be the last. In 250 million years, scientists predict a new supercontinent, Pangea Proxima, will form. The Atlantic will close. The Americas will crash back into Africa. The cycle will complete. So, as you drift towards sleep, visualize the slow, rhythmic breathing of the planet. Continents merging and separating like clouds in a slow-motion sky. The impermanence of the mountain, the fluidity of the stone. We are small, fleeting travelers on a magnificent, shifting vessel. There is peace in this vastness. There is comfort in knowing that the earth holds us, whether it is one land or many. The deep time of the world wraps around us like a warm blanket. The ancient silence of the desert waits. The eternal rhythm of the ocean tides continues. And perhaps this is the real gift of imagining alternate worlds. Not the answers they provide, but the questions they open within us. What does it mean for a world to have borders when the earth itself recognizes none? What does it mean to be separate when separation is just a temporary state in the endless dance of stone and time? What does it mean to be human when the very shape of the land beneath us determines so much of who we become? In our world, geography has shaped everything, not just where we live, but how we think, what languages we speak, what gods we worship, what dreams we dream. The Mediterranean Sea created the conditions for classical civilization, a highway of trade and ideas connecting dozens of cultures around its shores. The Atlantic Ocean was a barrier for millennia, until suddenly it became a bridge, linking the old world and the new in ways that transformed both forever. The Himalayas isolated India, the Sahara divided Africa, the Pacific scattered Polynesia across 1,000 islands. Every ocean, every mountain range, every river valley has written its signature into human history. But on eternal Pangea, none of these divisions exist, and so humanity, if humanity exists at all, would be fundamentally different, not in biology perhaps, but in psychology, in the deep structures of thought that come from living in a world with no horizons to cross, no frontiers to discover, no unknown lands calling from beyond the sea. There would be no Odyssey because there is nowhere to voyage to. There would be no Columbus because there are no Americas to discover. There would be no Magellan because the ocean is not a path but a wall. And yet, would that world be poorer for it? Or would it simply be different, with its own forms of adventure, its own frontiers internal rather than external, its own heroes who journey not across space, but through time, through the seasons, through the cycles of drought and flood that define existence on the supercontinent? Perhaps the great explorers of Pangea are not those who sail to distant lands, but those who learn to read the wind so well they can predict the monsoon 3 months in advance. Perhaps the great conquerors are not those who claim new territories, but those who discover new wells in the deep desert, new routes through the interior, are new ways to survive the extremes of a world that swings between fire and ice with every passing season. There is a kind of humility that comes from contemplating deep time, from really trying to grasp the immensity of hundreds of millions of years, the slow, patient movements of continents across the face of the earth, the rise and fall of mountains, the birth and death of oceans. We measure our lives in decades. We measure our civilizations in millennia. But the earth measures its time in eons. In periods so vast that entire mountain ranges can rise and erode to nothing. Entire oceans can open and close. Entire supercontinents can assemble and scatter like puzzle pieces on a table that has all the time in the world. And in that perspective, the question of whether Pangea broke apart or remained whole becomes almost inconsequential. Not because it doesn't matter to the life that inhabits the planet, but because both outcomes are just temporary states in a process that has no beginning we can identify and no end we can foresee. The continents that exist today will merge again. The supercontinent that forms will break apart again. The cycle continues, indifferent to the brief flicker of consciousness that observes it, indifferent to our preference for one outcome over another, indifferent to everything except the inexorable mathematics of heat and pressure and time. Now, yet there is beauty in this indifference, a kind of cosmic equanimity that offers its own form of peace. The Earth does not care if we understand it. It does not care if we survive or perish. It will continue its slow dance through space, its continents drifting, its oceans opening and closing, its mountains rising and falling, long after we are gone. Long after every trace of our civilization has been subducted back into the mantle and melted and reformed into new stone that will rise again as new mountains in a world so different from ours that we would not recognize it. And perhaps that is the ultimate lesson of the eternal Pangea thought experiment. Not that isolation is necessary for diversity, though it is, or that geography shapes destiny, though it does, but that the universe of possibilities is vast beyond our imagining. That for every path history takes, there are countless paths not taken, countless alternate worlds that shimmer in the realm of the hypothetical. Never quite real, but never quite unreal either, existing in that strange liminal space where imagination and science intersect. What would we be if we could somehow glimpse all those parallel worlds, all those alternate Earths where different choices were made, different accidents occurred, different outcomes unfolded? Would we feel regret for the paths not taken? Would we feel gratitude for the randomness that led to this particular configuration of continents and oceans and life? Or would we simply feel overwhelmed by the sheer magnitude of possibility? The recognition that reality is just one thread in an infinite tapestry of potential realities, each as valid as the next, each with its own beauty and tragedy and wonder. Tonight, as you lie in the darkness, listening to your own breath, feeling the weight of your body against the mattress, you are lying on the North American plate, or the Eurasian plate, or the African plate, or one of the other great rafts of stone that carry us through time. Beneath you, kilometers down, the rock is slowly flowing, moving at the speed of a growing fingernail, but moving nonetheless, carrying you and everything you know towards some future configuration that will not be realized for millions of years. The up your body were once part of the supercontinent, were once dinosaur bone or ancient fern or primordial ocean, and will someday be part of whatever world exists when the continents merge again into the next Pangea, the next Rodinia, the next supercontinent whose name we cannot yet speak because it exists only in the distant future, are in the realm of geological prophecy. You are made of star stuff, as Carl Sagan reminded us, but you are also made of continent stuff, made of the same silicon and carbon and oxygen that has been cycling through the Earth system for 4.5 billion years. The same atoms that witnessed the formation of the first oceans, the rise of the first life, the dance of the continents through their endless cycle of unity and separation. You are not separate from deep time. You are an expression of it, a brief, conscious moment in the ongoing story of matter organizing itself into ever more complex forms, experiencing itself, contemplating itself, wondering at the mystery of its own existence. And in this moment, drifting between waking and sleeping, between the world that is and the world that might have been, there is no need to resolve the question of which world would be better, which outcome more desirable. Both worlds exist in the space of imagination. Both worlds teach us something about the interplay of chance and necessity, of randomness and pattern, of the forces that shape not just landscapes, but the life that inhabits those landscapes. The eternal Pangea is not better or worse than our fragmented world. It is simply different, and in that difference lies insight. It shows us that the diversity we take for granted, the separate continents with their unique floras and faunas, the distinct human cultures with their different languages and customs, the complex geopolitical reality of nations and borders is not inevitable but contingent, the result of a particular sequence of geological events that could have unfolded differently, that did unfold differently in the parallel worlds of speculation and imagination. And so we return to the beginning, to the moment 175 million years ago when the crust might have healed instead of broken, when the Atlantic might have remained a phantom, when Pangea might have endured. We return to that pivot point not to wish for a different outcome, but to appreciate the outcome we have, to recognize the gift of the fragmented world with all its beautiful, terrible diversity, its oceans that connect and divide us simultaneously, its continents that offer both refuge and isolation, its endless variety of landscapes and climates and ecosystems that have given rise to the astonishing complexity of life we see around us. In the end, perhaps the real question is not, what if Pangea never broke apart, but rather, what can we learn from imagining a world where it didn't? And the answer, perhaps, is simply this, that we live in a contingent universe where small changes in initial conditions can lead to radically different outcomes, where the shape of the land influences the shape of life, where geography and biology and culture are intertwined in ways so complex we are only beginning to understand them. As sleep comes closer now, let these thoughts settle gently, like sediment drifting down through still water to rest on the ocean floor. There is no urgency to understand everything, no pressure to resolve all questions, no need to choose between the world that is and the world that might have been. Both exist. Both are real in their own way. Both offer their own forms of wonder. The night deepens around you. The same stars that shone over Pangea 200 million years ago shine over our fragmented world tonight. The same moon pulls the same tides, though the shorelines have moved, though the map has been redrawn, though the continents have wandered. The Earth continues its slow spin through the darkness of space, carrying its cargo of life and stone and water, oblivious to our speculations, indifferent to our alternate histories, magnificent in its patient endurance. And somewhere in the deep places of the planet, where the pressure is immense and the temperature is measured in thousands of degrees, the rock is still flowing, still moving, still driving the dance of the continents, still writing the story of the Earth in movements so slow they are invisible to us, so vast they encompass millions of years, but so powerful they can tear continents apart or press them back together as easily as we might tear paper or press our hands together in the darkness before sleep. Let yourself drift now, carried on the current of deep time, floating on the surface of the great slow ocean of stone that underlies everything we know, everything we are. There is nothing to hold on to and no need to hold on. The Earth will carry you. It has carried countless generations before you and will carry countless generations after you. You are safe in the vastness. You are held by the deep time that knows no hurry, no anxiety, no fear. Everything is moving, everything is changing, and yet everything is exactly where it needs to be. The continents drift at their own pace. The mountains rise and fall in their own time. The oceans open and close with the patience of eons. And you, in this brief moment of consciousness, are in this fleeting instant of awareness, are part of it all, woven into the fabric of deep time, one thread in the infinite tapestry of existence. Rest now in that knowledge, rest in the peace of impermanence, rest in the comfort of deep time. CTA 3. And whenever you're ready to explore another world, we'll be here.